Thank you all for joining. So, really glad to meet you all here. And first of all, thank you for joining. So, thank you also for the introduction. So, as some of you may know me, my name is Eli. It's Eliezer in Portuguese, but most people call me Eli. So, I'll be jumping around multiple screens. So, maybe first of all, this will be a 90-minute workshop. So, grab a water, grab a coffee. It will be a very long ride. So first of all, I just want to, do a quick introduction. So about me. So you folks can find me on GitHub on my TELUS handler. It's Eliezer WT. The content from this presentation will be all under this repo called KTTMLS AI Containers 2025. So all the content will be there. You folks can check the samples. You can check the slides. It's all already there. So if you need to drop, you can find the content in there. Second, as folks mentioned in the introduction, I'm part of a great team on TELUS. Its name is TELUS AI Accelerator. It has very diversity of projects and ideas. We try to accelerate the TELUS business by applying AI solutions in several different fields. So please check them out. Their page on LinkedIn is TELUS AI Accelerator. So a lot of great people, a lot of great folks. So yeah, check them out. And also just a shout out for FuelIX. So FuelIX is a TELUS product that we use in our day-to-day development life. So if you want to check them out, what FuelIX is, what they are doing, also give a look on their LinkedIn pages. A series of interesting things. In the age of the AI, and I think this will be the initial parts of this presentation, a little bit of yapping, right? It's containers, right? Everyone is talking about Docker. At least they used to talk a couple of months ago or years ago, and how containers could make your applications deployable, right? And I think the initial part of this presentation will be understanding what is Docker, why do you use Docker, why it's important. And after that, we start moving a little bit further into the next stage that is, okay, how do I make my applications be deployable via Docker? And then we go to another stage that is, okay, I want to use other people's applications. And then the final stage, there is like the end act is, okay, how we put together all of these multiple applications alongside with my application in order to build a full-fledged system that we can think on deploying on cloud applications. And of course, many of these things will be either AI applications or they will use some sort of AI capabilities, right? So in order for us to get doing all those cool stuff, we need first understand a little bit about what is Docker, right? So we all live in the age of AI, right? So what is Docker? What is Docker all about? So if I just grab, AI answer, they will say that Docker is an open source platforms that will allow you to automate the deployment, scaling, and management of applications using containerization. And containers are these lightweight, isolated environments that contain everything needed to run an application, including the code, runtime, system tools, and libraries, right? So that's a very generic explanation, but I think it defines very well. But I think if I could pick up a meme to describe what is Docker, it's like, you're just doing your code, just vibe coding. It's running in your computer. And then, you need to ship your product and you have, just 2 days to do it. Then your manager say, okay, is it's working on your computer or let's just ship your computer, right? So that's how Docker was born, right? So right at the beginning, you had to specify, well, my application will need on your server X version of this package. You need a C URL installed on version 2.17. If you have a different version, it will break the environment. But then there is another application running on that server that uses a different version. And then versions were, breaking each other. It was a madness, right? So Docker was born into this idea of let's take this environment that's where your application is working and let's have multiple copies of this where people can run in multiple servers or run into their cluster or anything like that, where you will have full control of what are the requirements for your application and how your application will run in this environment. So if you need a specific version of a package, then you have it installed on that Docker container. If you had a specifically setup that you needed in the operational system, you could have it as well. So it was very practical because you just removed all that fuss about setting packages in the server, conflicting packages between versions. It was really great, right? But also, it's important to define what Docker is not, right? So what is Docker not about? The most common sort of misunderstanding, and not really misunderstanding, but people take Docker as a virtual machine, right? So imagine that you install something like VMware, or you install something like a VirtualBox where you can install Windows and then click around with your mouse. So Docker, it's a type of virtual machine, but it's not that one. So the first little bit of misconception would be that one. The second one is that, okay, because I'm running on a Docker environment, I'm full secured against anything because I'm not running in an actual computer. I'm running in this closed box environment that's called Docker, and it's all heaven. It's safe. I don't need to worry about security. I don't need to worry about package vulnerability. So it's not that reality, right? So we know already that there are vulnerabilities that allow users to get access to the host computer from a Docker container. So that is a misunderstanding. The next one is that Docker is not the end deployment solution. So many people think that now that I put it in a Docker container, it's done. Now my application is ready. So it's ready to be deployed. It's on the path to be deployed, but there are other end solutions that will be served the better purposes for scaling, for deployment. And this apply not just to AI applications, but also applies to other types of applications, or vice versa. I would say that it applies to all applications, including the AI applications, because in the end of the day, your application will be living in a cluster or in a type of managed environment that will allow scaling and increasing the number of copies of your container, or making it more reliable, adding observability and all of that. Many people also think that Docker is the only container solution. So, and this is a very interesting point. There are other solutions out there in the market, such as Podman and LXC. And now, I think this week on WWDC, Apple is now announced that they are developing their own Apple native container tool. So Docker is just a flavor of container. Maybe it's the first one that appeared, but right now there are other tools that allow you to achieve the same type of containerization that Docker allows. And about Docker Desktop. So Docker and Docker Desktop are two different things. So Docker Desktop is not a free software, so you need to have an account to use. You can use it for free, but only for personal purposes. So Docker Desktop is not a free software, although Docker is a free software. So tricky to understand. What you need to know is that if you are running on Mac, for instance, you probably need to use Docker Desktop. There are no other ways of having it. If you're running on Linux, then it's all good. You can install the Docker without Docker Desktop and keep using. But let's move on. So what do I need to run a Docker container, right? So depending on the operational system where you're running, you have different sets of requirements. For those here who are using Windows, the easiest way for you to get Docker on your computer is to install WSL. That is the Windows Subsystem Linux, and the Docker Desktop. So they both run together to make sure that you can use Docker locally. If you're running on macOS, then the only way to do that is installing Docker Desktop. If you are on Linux, then install the default Docker service. If you go to the Docker page, you have a very simple script that you can run and then get you started. If you are on Windows or Mac, there is this detail that for using Docker, you will need to have Docker Desktop open all the time for running. Now, macOS is a little bit more smarter, and I think Windows is doing as well. So if you're starting a container, it will pop up the Docker Desktop screen for you to use. Okay, so maybe let me just give you folks a quick view. So what is Docker Desktop? So Docker Desktop is this very tiny window. Let me share here. So this is Docker Desktop. So Docker Desktop is this pretty app where you can see what are the containers, what are the images that you have, what are the volumes, Docker Hub, and all of that. So this is mainly Docker Desktop. So whenever you go to the app and you download the Docker desktop application, this is what you're going to get. So maybe let me show a bit on the Docker desktop page. So this is the Docker website. So if you want to download your own Docker, you can go and download Docker desktop for Mac, for Windows, and I think now you have Docker desktop for Linux as well. So right now, this is the easiest way that you can get for having a running. So this is the first place you need to go, downloading Docker on your computer. Okay, so with Docker installed, as you folks saw, there are two different naming conventions and concepts that we need to understand. That there is Docker images and there are Docker containers. So we can understand Docker image as this static, portable, and shared package that contains the application and the dependencies. So a Docker image, it's defined by what we call Docker file. And after the building process, it receives a name and a tag using a very simple pattern called name and tag. So here I have an example. You could have a Python, and then you have a tag. Python will be the name of the image, and then you have a version that 3.13. You could have Node, and then have a tag name that is 20. You could have a name that is Debian, and then a tag that is Bookworm. So it really depends on what is the package and how they decide to do the naming. But what is given, and it's always true, is that a Docker image always has a Docker file linked to it. And in this Docker file, what you have, it's a definition of how that image is created. So what are the packages that you need to install? What are the files that you need to put into to make sure that your application will run once you are in your deployment environment? Then there's another thing that's called Docker container. So Docker container are the running instances of these images. So they provide the isolated and dynamic running environment for the application. So after a container is started, it will receive a random generated ID and also a readable name. So you have an image, you created your Docker file, you created your Docker image. So at the moment that your image starts running, it becomes a Docker container. So a single Docker image can become multiple copies of these containers. So each container will have its own ID and its own name, but all of them could have the same base Docker image. So let's say that you have an API that you want to scale up and it's all stateless. So you can just create multiple containers based on that same image. So that is the idea. So imagine that Docker image is your recipe. If you are familiar with cooking, Docker image, it's your recipe, and Docker container are the dishes that you are making out of that recipe. So you can make several dishes, several copies of that dish, but using the same original recipe. So how these recipes look like? Okay, so actually, how do I create one of these Docker containers, right? How do I run? So it's very simple, very simple steps. The first one you need to have, it's Docker desktop or Docker service running on your computer. The second thing, it's what image do you want to use? What is the recipe that you want to use for running this container? You also have another option that is building your own image, but we'll get there very soon. For running your container on your console, there are mainly two ways for running it. The first one is running using a very simple command called Docker run. Then there's this magic parameter that you'll get there in a sec. And then there is the name and the tag of the image that you want to run. So here, let's say we're running Python 3.13. We also have the option of running a very specific applications. So let's say that you want to run Bean Bash on these from this container. You can as well just passing an additional parameter saying, well, I want to run Docker run, I want to run this image, and I want to use this application from that container. So that is also possible. So maybe let me share now a little bit of how this works. I'm in my computer, so Docker has, whenever you install Docker Desktop, you get a bunch of commands. So you have the Docker PS, you have Docker LS, you have Docker images. But the first one, so Docker run, right? So this is how it starts. So I can say Docker run Python, and then say that this is the image that I want to run. And once I click, it runs and it's ready. So the image was downloaded, the image executed, and the image exited. So if I add now here the minus IT that I added into the presentation, you see that now instead of just having the application, the container to run and leave, now you see that it's interactive and I can, just use any Python command that I want in my command line. So, that's great. So now I can run Python on the version 3.13, and it's working. But now let's say I want to run a very old version of Python. I want to run Python 3.10. And not that old, right? So Docker will say, well, I don't have that image locally, so I need to download it. So it will download the image automatically for you. And once the download is finished, it will drop into the Python console, right? So, and then you see here that now you are on a 3.10.18 environment of Python. So that's pretty cool. So you can have your application running on any version that you need. You just need to specify what is this base image that you want to use. And now, just for completeness, let's now to, instead of running Python, let's run bash when you are entering your container. And here you see that now instead of a Python console, I have a bash shell for me to interact. And then you see here that this is actually a Debian Linux and not my Mac OS operational system that I'm running on. So whenever you run this command directly into your Docker, you are entering another computer. And then here you can see, okay, if I run Python 3 now in this console, you get into the 3.10 version of Python. Okay, so yeah, so if I leave Python now, I'm still into the shell on the container. If I exit them, I'm back on my regular shell. So let me now go back to, okay, there is another interesting thing that is, so what are these recipes, right? How do I know which versions I have available for me to use? So Docker, now it's, Docker company. So we have what it's named repositories, right? So repositories, you can see it as a list of recipes that you can use for, for cooking your cookies, right? For the recipes for your cookies. So imagine that you have many flavors of cookies and you want to know, okay, which flavors do I have? So if you go to Docker Hub, now Docker Hub has a lot of stuff involving GenAI, but if you go, let's say, to languages and frameworks, right? So here you see a list of all the images that you can use from the Docker Hub repository. So Docker Hub repository is the default hub for all the containers available. So if you want to download a Python, this is the Python that you are pulling. So whenever you say, Docker run Python, this is the Python that you are running. Same thing for Node, same thing for Golang, same thing for Ruby and all the other languages. So, okay, but how about the tags? How do I know which tags I have available? So once you pick it up, the Python one, you see here there is a tags tab, and then you see, okay, there is the tree/sling bullseye, there is the tree/bullseye, then there is the tree alpine. It gets very large. Then there is the 3.13.5 sling, and we can go very far. So if you go on official images again, then you see there is Redis, there is Postgres, there is Ubuntu, there is Node, there is a lot of flavors that you can use. Okay, but let's say that you are not using. So is Docker Hub the only place that you can find images? The answer is no. Right now, there are multiple repositories for Docker images. There is GCR from Google. So Google now has its own container registry. I think it's GCR. uh, Google Container Registry. So it hosts these images as well. You can, I think it's Artifact Registry, how they're calling, but same type of capability. You can find images hosted there. I think GitHub now has their own hosting for images. So hosting images is a separate thing. So for now, let's just stick with Docker Hub and what is available in Docker Hub. Interesting things for running things on production, running applications in production, is always check for official images. Because you are running your application into a container that maybe someone else built, you want to be certified that nobody added into that container something you didn't want it, right? So checking for official images is always interesting. So you never want to, okay, which images do I pick? So always filter out either for Docker official images or for a verified publisher. All of that is very helpful for you to pick up a safe Docker image for your application. I saw there's a question. I'll take a look in right. I'll get there right in a moment. So I just gave you an example on how do you do a Docker run, a very simple one, right? So if you are doing a Docker run Debian latest, then you have a very simple Docker run. But things start to stack pretty fast. So you can have a much more complex Docker run. And this is what you see whenever you're browsing for a suggestion or for a tutorial or in a getting started guide. So here I have a more complicated Docker run example. So in this Docker run, you see a name. So I'm giving a name for this container that I'm running. I'm giving a -rm. So, and this is interesting for you folks to be aware, like whenever you run a container, if you don't specify, this container will stay on your computer until you remove it from there. So if you are running Docker run -rm, after your application or this container ends its execution, it just gets deleted off your computer. So it does not bloat it. Your disk for gigs of data. There's another option that is the -it. So this will allow you to interact with that container using the standard input of your computer. So you saw the difference when I run before without the IT. My application just started and finished without any type of interaction. But after I added the -it, then I was able to interact with the Python console and give it commands and read what was the output. So if you are planning to interact with that container, the -it becomes very important. Another very important thing is that if you are running an application, you probably want to read environment variables. So you need the address for your application, you need a default setting for your VectorDB configuration, you need an API key for OpenAI for having your packages running properly. So usually the right way or the way that you want to do is passing that as an environment variable. So there are mainly two ways of passing environment variables. You can set the -e, what is the name of the variable and what is the value, or you can pass an environment file and then it's -m file, and that will allow you to pass a list of all the variables that you want to set into that execution of the container. Another very important thing, and that we will use quite a lot very soon, is the ports that you want to use. So if you are hosting a web application, you want to access that application in your local computer. So the -p parameter will allow you to take a part where your application is running in the container and expose that to your host computer. What does that mean? So if I'm running without this -p, if I'm running without the -p, I'll not be able to reach that application in my container. However, if I use the -p, my application that before was running on the port 8080, now it will run on the port 5000 in my computer. So I can access the web application even if that web application is running within the container. So that's what's pretty cool. So for people who use GPUs or have more experience, there is a parameter that allows mapping all of the GPU devices from your host computer into your container. So there is this -- GPUs. And then at the end, we have the regular commands that we were using before. what is the container image, what is the tag, and what is the application that you want to run. I'll do a first demo. So the first demo that I will do, it's, okay, I want to run other people containers. So we saw many cool containers on Docker Hub, and now I want to run those applications in my machine, right? So the application that I choose it to be the first one is an application called Arise Phoenix. So there is a company called Arise. Arise develops a solution for monitoring large language models. Oh, let me find here. I have it open here. Arise. Yeah, so this is Arise Phoenix. So Arise Phoenix is a platform for, some of you may be familiar with LangFuse. So Phoenix is a type of LangFuse. So it's an open source LLM tracing and evaluation platform. It allows you to connect your LLM applications into it and then monitor all, what are the traces, what are the token usage of your application, how much your application costed. So there are different ways that you can use the solution developed by Arise. One of them is you can, get started and subscribe to a Rise service. You pay for a fee for your software. But there's another option that is self-hosting your Phoenix instance. And by self-hosting your Phoenix system, it will allow you to, okay, I don't need to pay this super cool tool that's available already. So it's an open source tool you can just run in your computer. So this is a little bit of the idea that I wanted to bring to this presentation. So there are many, many tools that we can use for doing AI development these days. Many of these tools are open source, but they always have this version that you have to pay for having access on the cloud. But sometimes you just want to do, your very little project. You don't really want to give the data that you are using for this company, whichever it is, right? I just want to test my sample app and see how it works, and maybe see if I want to buy this for my project or for the company that I work for. So it's pretty cool that many of these open source technologies, they have, this version where you can go and run your own application. But if you don't know Docker, if Docker is still something mysterious to you, it's very hard for you to, okay, how do I do this? Where do I get started? So here on the Phoenix page, you see on the self-hosting tab, here on the Docker, you see that, you can do the deployment using Docker. And this is the image that it's being used. And here, we just follow it into the Docker Hub, that website with the cool recipes that I was just mentioning you. So here there is a description of what is the image, how does it work, and then you'll say, what are the requirements for you to use? So there is here Docker, so you can run a local instance of Arise Phoenix in Docker with 2 commands. So the first one is Docker pull. So Docker pull is basically taking this image from Docker Hub and pulling into your computer. And the second one is the Docker run. And that is a command that we just saw, right? We just understood that by doing Docker run -p, I'm running this container here in the latest version, and I am setting the port 6006 from my container into the 6006 of my host, and the port 4317 from my container into the 4317 of my host. So what we're going to do now, we're just going to copy this pull command. I will just share now again my other tab. You are seeing probably more things, so just give it a zoom. So the first thing that it says in that guide, right, it's Docker pull. So when I give Docker pull, what's going to happen is I'm going to download that image into my computer. I already have it here, so I already had downloaded. So now you see that if I do Docker images ls, Docker ls images, okay, Docker images. So Docker images, I'll see that there is an Arise Phoenix now in my computer, and it has 1.02 gigs. So now that I have this image here that I already downloaded, next step is to run in my computer. So what I'm going to do is I'm going to go back to the Arise page. I'll just copy this command, and I'll just say, command B, paste it, and then it will create the instance of this machine, and then it started running. So now it done all the things that it had to be done. It created all the database. This is literally another application coming and running into my computer without me having to install any extra package, any extra setting, just running out of the box. Isn't that beautiful? So now if I just go here, there are two addresses here at the bottom. And something very interesting for us to keep in mind is, remember when we were running this command, we were setting it up like two ports, the port 6006 and the 4317. So probably our application will be visible to my host computer using one of these two ports. So here we see also in the logs that Uvicorn is running on 0.0.0.6006. So now let's give it a try. So let's try to go to localhost 6006. So you see that something is happening, and then here I have Arise Phoenix running in my computer. So this is my instance. So if I just disconnect from internet, I can keep running this instance as long as I want. And here I can have a look in the Phoenix Arise platform, and I can see, okay, I can have my custom data set. I can go here, I can create a new data set. I can go here, I can create a new project. I can start monitoring my application. So this is really the beauty of having the capability of knowing and understanding how to run your own applications. And if you go to LangFuse, so as I was saying, so there are other platforms that do tracing evaluation. So if you go to LangFuse, you find a very similar model approach. So you can go here, you can go in docs, and then you see here on self-host, right? You see, same sort of, I'll just increase a little bit. So if I go here on self-host as well, you see there is recommendations on how you can run these yourself. So having this base knowledge of, okay, so this is how I would run my application. So that is the idea here. So now we know how we can run our own platform for having tracing monitoring. So you probably have to set up your OpenAI key or your other settings, but you can do that here on settings. You can set what are your AI providers, and we'll get into that in a moment. So I think this is our first example. So this is Phoenix. So if you folks want to check it out, Arise Phoenix on Google. You get to the page very fast. I think we have a question, so I will take a look here right now. What is the question we have? Is that a bird house at the back? A bird house? No, it's not a bird house. It's a cat house. So this is something that my wife bought, and it's called Polecat. So my cats can go and jump into and play around. So they are a little bit fancy, and then they stay inside the house for just sneaking while we are at our work. So it's Polecat. Okay, so let's move on to our next topic. So what is a Docker file? And I'll just maybe keep sharing like this. I think the letters are big. So recapping, we just learned how we can run other people's Docker images. So other people package their applications, and we are now able to run in our computer. But we are very hive-minded people, and we want to make sure that we can give our applications to other people so they can run them as well, right? So the easiest and the first, actually it's not the easiest, but the first step in doing so is to write our own Docker files. So remember when I mentioned that you are using a recipe to create your cookies. So now we're writing our own recipes for cookies. So we are creating our stuff. So this is a very simple Docker file. So we are creating here a Docker image that is based on Python 3.13. Our application folder will be app. We are using the user 1001, so we don't want to run as a root user because that's not very safe. And we want to copy like our main.py file it within our container. And then I want to set my entry point to be the Python tree, and then to run the app.main, app/main.py file into our container. So this is my recipe. So I'll just stop here. My Arise Phoenix. I'll join here my samples. I'll run here. Oops, this is the Phoenix example. So I'll just go back, go into demo queue. And then I'll show here that we have, this Docker file. It's exactly the same one that I had in the presentation. So Python, work this, user, very simple. But now you see that there is a main file here, a main.py file. So in this main.py file, we have a very simple message that is hello world, TML LS 2025. So this is my application. So I want to ship this application to as many people I want, and I want to create this recipe. So usually this is how you will structure. So the root file of your project will have this Docker file, and this Docker file will have a recipe of how this container will run your application. And then I'll just do a quick parenthesis here that the beauty of Dockerfile is not just that, you're packaging your application and sending to someone else, but this also works as documentation. Because imagine that you are trying to run someone else's app and they have a Docker file. Even if you don't know what is Docker, or if you don't have a Docker environment set up for you to use, you can just go to the Docker file and see, okay, what they are doing. They are just, taking a Python 3.13 version, and they are just copying the file and running the app as a non-user. So that should be enough for you to run yourself in your computer, even outside of a Docker environment. So that's the interesting part. So even if you're not doing the cookies recipe, you know what you need in case you want to do. So that is interesting part. So Dockerfile are this sort of living documentation of what your application needs to run. So, okay, so how do I run? So I wrote my recipe. We all wrote our recipe for the hello world. So to run your custom Docker file, so there are two steps. So the first one is building your Docker file. And the second one is running your Docker file. So you always have to build your Docker file in order to use it. So how do you do that? So there is one very simple command that you can use. There is Docker build. So Docker build also has a series of parameters that you can use if you want. Here, I'm just going to use some of them. So the more common instance is you say Docker build, and what is the Docker file that you want to build. And then you can add the -- tag, and then say what is the image name that you want to give, and what is the tag that you want to give to that image. You can run, instead of saying Docker file or which is the Docker file that you want to run, you can just say Docker build dot, and it will understand that the context that you are giving is your current folder. So let's try to do that. So let's go to our folder here. So we have our Docker file, our main file. I would just say Docker build. I'll say Docker file because that's my file. And I'll use the tag TMLS, and I'll use that this is v1, right? So I'll just hit enter. Oops, it didn't like it, my Docker file. I think I have to add, okay, it didn't like it. So let's just do the Docker build dot, and then say, okay, this is working. And then let's try to add the -- tag TMLS, and then say this is v1. So, okay, so this is running. It just didn't like it, the Docker file syntax. So it's fine. So Docker build builds our image. So now remember when I done before the Docker images and look it into here, that there was the Arise Phoenix. So now you see that there is this TMLS image. There is one tagged as latest, and then there is another one tagged as v1. So I don't know why it's created 2 hours ago, but I'll just give a different name. So let's just Docker build. Now let's just call custom image, right? So, okay, I'll just Docker image. And then there is custom image. Because I built a copy of this 4 hours ago, maybe that's why it's, because it will not rebuild because I didn't change anything. So let's force the magic to happen. So I'll just edit my Docker file. I'll just change these to be 3.9. So a much older version of Python. So I'll just Docker build. So now my computer is downloading that image that I don't have locally and is running the recipe, right? So here you'll see that there is a number 1 where I'm downloading the image from Docker Hub. There is the step 2 that I'm changing my work there. Then there is the step 3 that I'm copying my main file from the repository where I am into that container. So you see, it's literally a recipe, step-by-step execution of what had been defined into that Docker file. So if I go now to Docker images again, now you see that custom image had been built 31 seconds ago. So what we do next? So next step is running our container, running this container using that image that we just built. So by doing that, we'll just say docker run --rm because we don't want to keep that container after it run. The minus IT for having some possible interaction, and then the name of the container and the tag that we just gave it. So docker run --rm -it, and then the container name that is custom image. It's custom image, right? Custom image, and then the tag is v1. So hello world tmls. So that's what our Python script was doing. So pretty simple, pretty straightforward. So now let's understand what was actually going on, right? Because here I only have this Docker file and the main.py. But what is in that container? So now let's run our bash command. Oops. Why don't you run? Oh, okay. So it's not going to happen. But when we are running our Docker file here, we are copying these main.py into the container. So now the file, if I change here, just give an example, right? So now I'll just change this message here to 2026, right? Let's jump into the future. So I saved that main file. So if I look at the main file again, 2026, if I just run my image again, we'll see that it's 2025, right? So nothing changed. So this means that why that is happening? Because we built that image, we are packaging our current application as it is in that moment. So the fact that I'm changing a file in the same folder doesn't mean that this file is changing in that image that I just built. So now, what if I want to have the changes that I just did reflected into my container? What I need to do is I need to rebuild that image with a new tag. So v2. So okay, I rebuild it. I don't need to download that because I already have. So now if I just change and run the v2, I have 2026. Because I built my images with different tags, now I can run with v1 and it's there. So I have 2025 and I have 2026. So this is the simple fundamentals of running your custom applications, right? So I just did the demo. So this is demo number 2. So we run our simple Python container doing our hello world. So now let's move a little bit further into like complexity. So Docker has a lot of useful commands. So we can use Docker pull for pulling images into our computer. We can use Docker push for pushing our custom images to a repository. We can run Docker PS to see, do I have any images running on my computer right now? We can use Docker build to build our Docker files. We can use Docker run to run our images. And we can run Docker compose for orchestrating small networks of containers. There's a cheat sheet here on the Docker website that has a lot of helpful commands, helpful, useful stuff for you to run and how to install, what are commands you need to use often, how do you build, how do you get logs. So it's a very useful cheat sheet for those who are interested. Okay, so where can I use the Docker container? So there are 2 main usages here that I'll just give an example. So the first one is dev containers, and for folks who know me, I really like dev containers. Dev containers are these super small embedded environments where you can set an environment for development, and then you can use that into your environment for building. So if you search here on VS Code extension for dev containers, you see that there is 31 million downloads. So there's a bunch of people using right now because this uses a Docker file or a Docker container as your development environment. So everyone in your team is using the same exact copy of an environment. And that's very good if you're using pandas or if you're using OpenAI packages, because sometimes someone just decides to upgrade their version of their package, and all of a sudden application is not working, and then you realize, okay, I'm running a different version, and then you do a change, it's not available in the other, and everyone gets with a messed up environment. So very good to normalize your environment. Another very interesting advantage of using development containers is that if I go here into my profile and I take these repo that has the presentation, GitHub has a very neat feature that is called code spaces. So code spaces use these dev containers files to create an instance for you to code on the fly with GitHub. So you can say, create a code space for me. So what's going to do is going to take that dev container file that you have set up into your repo, and it'll give you a VS Code version with all those applications that you defined in your dev container for you to use on the fly. So containers are very useful because they allow you to specify what do you need to do a development in this project. So I don't know what's the pricing of code spaces, to be honest. I think you may have 1 or 2 code spaces for free for testing, but you can take a look if you're interested. But the whole idea of, okay, I'm not in my computer, I don't have a setup, I don't have a Linux machine, I don't have Docker. You can just use some of these capabilities of creating this dynamic machines for you to develop on the go. So pretty cool stuff from GitHub. So another thing that then becomes very interesting is that if you want to deploy this application that we just developed, you can rely on technologies such as Kubernetes to do the deployment of not just one copy of your container, but as many copies of that container as you need. So if you need to scale a web application, if you need to scale some ETL process that you're running, Kubernetes can handle and do that trick for you depending on your load. So Kubernetes, for those who are not familiar with the name, it's an orchestrator platform. So it's a set of computers that are put together to run very diverse and heavy loads of application. So you can run, let's say, 30 different applications in a cluster with 2 different nodes, where each node is a computer. So it's a virtualization platform that will allow you to have a lot of control into your deployments. So there's a lot of applications that run on top of Kubernetes. On the AI space specifically, you find Kubeflow. If you folks are not familiar, Kubeflow, it's an automation platform that runs on top of Kubernetes. There is another alternative to Kubeflow that is named Argo Workflows. Also works similarly to how Kubeflow works, trying to get these very small containers doing very specialized tasks, such as ETL processing, such as very small inference, and create these workflows that can process this data on a schedule or on a trigger. So very interesting technology if you are interested just in the final applications and how to automate your application. What is the interesting thing about this is that Kubeflow and Argo both rely a lot in the container. So imagine that now our little application here that instead of saying hello world, it's doing a processing, right? So if your Python app do the processing, it needs to be in a container in order to be put it into these workflow technologies. So that's how important containers are these days. Okay, so now that I told you all about a little bit about the Kubernetes, let me try to go back to my presentation if I can. Now, next step is orchestration, right? So Kubernetes is really like the end goal of every application platform. So let's say that we want to use orchestration, but now in a smaller scale, right? We want to run our application side by side some other application. And there are very, there are several cases that we can highlight where this becomes super important. One is example here, it's I have two applications. I have my application and my app school, and we have the Postgres database that I want to use at the same time. So these two applications need to talk to each other. So if my app is running, I need my database running as well. And then because I'm using a vector DB on Postgres database, I need them both to run together. So if I want to run my app, you have to have your Postgres instance. So Docker used to have this extra package that had been added into the default install that is named Docker Compose. So Docker Compose, and now we call it just Compose. It's a container orchestration tool that is built into Docker. So Compose uses compose.yaml files. They used to be called Docker compose.yaml files to define services and how they are going to run. And then using Docker Compose, you can trigger and run multiple of these services either individually or at the same time in your computer by using Docker Compose up. If you are building a custom image, then you have to pass the parameter that's -- build. And then you say Docker Compose up. All of these two services will be up together at the same time in your computer. Let's say that, okay, I'm tired of this. I don't want to run this anymore. So you can just type Docker Compose down, and all of this will be destroyed. What is interesting about this is that these two applications are going to live in the same network. So they can see each other and they can talk to each other. So that makes everything much more interesting to what we're going to do now. So first of all, let's just have a little glimpse on what is container orchestration. So I had put together here, again, another small sample so we can try. It's on demo tree. So here is our Docker file. Same Docker file we had before, nothing fancy, just copying the main file into the container. We're very familiar with that. However, I created a little bit more complex file here using root code. So if you folks don't know root code, it's a system very similar to GitHub Copilot. Here I have root code connected into FuelAX API. So the idea here is that I just ask it, hey, root code, can you write to me a very simple example code that just responds to an endpoint without using any extra package and say hello world. So this is my app. So it's a 44-line AI generated code that will do what I need to do. And then here I have my compose.yaml file. So compose.yaml file is a YAML file that will have these definitions, and each one of these blocks is a service, right? So if I wanted to have another copy of the service, I would just have, another service, and then I'll just give another name, and then I have two services. So this would run two different instances of my application. And then VS Code is a very smart IDE, and then it will have this little button that will allow me to run these services independently or run all the services in this file. So I'm not interested today in running using the support of VS Code, so I'll do a little bit on the hand, right? So let's go on demo 3 here. So same compose file, same Docker file. So if I cat compose, here is our application. So as I said, before we had to do Docker run --rm -it, the name of the image that I just built. So here I'll just say Docker compose up. And then it created my container. and then it's attached into my application already. So now because I exposed my ports, so if I go to localhost 8000, where is my browser? So let's open a new tab here. Localhost 8000. I'm being tricked by little gnomes. So I'll just Docker compose down because that's destroy everything that had been put together. Let me just cat my demo again. Okay, it's the hello world one. So let me Docker build. Actually, I don't need, so Docker compose up. And then I'll add the build parameter here. So this will force the build. So, okay. So now let's see again. I have ports 8000 mapped into the 5000. So let me see if I localhost 8000. Okay. So you see, hello world. So it's the same thing that I go into my command line and say docker run -p my container image. However, now I'm doing this in a much more elegant fashion, right? Because now instead of having that command run on CLI every time, I can have this very helpful definition file that allows me to specify, what is the environment file that I want to use, or what is the variable that I want to define, right? So this makes our life much, much more easier, especially if I'm thinking a little bit on that idea of documentation, of having these to serve multiple purposes as well. So as I said, now let's do a different thing. So I was playing around before on having more than once, right? So if I go here now and I create another service, and then I go here and I just do Docker compose up again. Now, oops, I cannot use the same port. So let me just change these to be 9000. Okay, if I just Docker compose up again, now you see that I have 2 copies of my application running. So one copy run on the 8000 and another one running on the 9000. So each one of these applications, each instance of this application is different, right? So now I go to a different hello world, but in fact, what I'm doing is reaching a different app that is running within this Docker container. So now I have 2 applications. They are the same application, but they are technically 2, and they are running together. So once I Control C here, Docker Compose will do the work for me of stopping those containers and making sure that nothing stays running behind. I'm not interested in using this anymore, so I can just say Docker compose down, and all the container used for this app are removed from my computer. So that gets very interesting, right? So one very example of more complicated example is using these compose. It's LangFuse itself, right? So LangFuse doesn't have a Docker version for you to run, but it does have a Docker Compose version for you to run. And here you see a very interesting LangFuse. Here you see a LangFuse worker, here a service, another one that is LangFuse Web. Here you see another one that is ClickHouse. Here you see there's Minio, and here you see there's Redis. Here you see there's Postgres. So it's a lot of dependencies, and having all of these defined in these compose files is what makes these Docker compose or these compose YAML files be so useful in the orchestration realm for local development, or even for some more simple deployment. Let's say that you were wanting to deploy your application in a single machine on GCP or on Azure or on AWS. You just boots up your EC2, runs your Docker Compose up within this computer, and your whole environment is ready to go. So it's as simple as that if you have your application in this nice and tidy fashion with Docker containers. So I talked a lot. I, said a bunch of stuff about many, random stuff, but we didn't do a lot of AI, right? And I think that's what I want to get. in our first example, and actually our last example. This is not the first by far. So let me just go back to my presentation here that I probably lost again. Okay. I need to get better in this eventually. Okay. So if I just go to the last one, so last slide. So now it's all fun and games. So now let's do, a little play around application using Oyama and Python, and then let's orchestrate this application using Compose. So I don't know if everyone knows about Oyama. Oyama is this sort of open source platform that allows you to run your own models for development. So if you can go to oyama.com, you can go here and you can see there are several models that you can run on your computer by just using Oyama. So it's pretty cool. You have a lot of models, open source models. You have DeepSeek, you have Gemma, you have a lot of good stuff. But how do I do this? How can I make my application, or how can I serve something self-serve? I don't want to pay OpenAI. I just want to use these things that are free. And I heard something that said that, there is, if I went to Docker Hub because I'm very, curious, and I learned that there is a Oyama Docker image. And, I want to do that, Oyama. I don't want to pay OpenAI. I want to use Oyama. Here, there is an image. There is a document. I just want to use this, right? So let's go. So here's our demo number 4, or last demo. So my application Docker file, it's pretty much the same. So I just included a new one that's just a pip install requests is here, pretty much standard. The rest of it, it's all our same very simple Docker file. I created here a Compose YAML. So my Compose YAML is also very simple, same pattern that I had before, my simple app building my current folder, and then our Oyama service running in the ports 11,434, pretty standard, nothing fancy. And because this Oyama instance is the one that I'm pulling from Docker Hub, I don't need to do anything. No authentication, no credentials, just Docker pull Oyama, all good. Seems good. So the final thing, I done some root code in here as well. And root code just code this awesome, awesome tool for us to do some testing. So what these two do is it basically creates a very simple front end using HTML where you can submit your query, and integrates with Oyama prompting using Model 5 because it's a little bit smaller. And then it runs an HTML server that connects into the Oyama server. So here you see that, and here is the interesting part, right? So I'm connecting to the Oyama instance using this Oyama address, right? But Oyama is not a web address, it's not. This doesn't exist. So this Oyama comes from the name of the service that I created here in my Compose YAML, right? So this is how I'm calling my service. My service is called Oyama. So from any app within this Compose environment, I can call it just using the name of that service. So here I'm saying, yeah, I want to talk to Oyama. I want to use this port, because if you see here, this is the port that I'm exposing in the service. And I want to hit the API generate endpoint. So this is the endpoint on Oyama platform that allows you to use something similar to chat completions on OpenAI. And this is going to prompt and say, well, this is the model that I want to use. So now let's try to use a little bit of the interesting things on VS Code and just click run service here. So yeah, it pop it up. Something is it trigger Oyama. So now if I go into my browser, localhost, and then hit that port, it's 11434, Oyama is running. Very little effort. I would say 0 effort. So now what we need to do is, okay, so Oyama is running. So I need to run my service now. So I click here, it built my application. It's running on the port 8000. So now let me change to port 8000. Here is my application. But this application, it's not really cool, right? So I would just ask Ru. So you folks, if you don't know Ru, so Ru Code, it's a platform, and then this is a little bit of how the cool kids say, like an Easter egg of the presentation. So RuCode is a coding assistant. It uses agents for doing these changes. So you can choose different agents to do the tasks that you want. So I really like using Orchestrator. Can you improve this page where I have to write my prompt to use some colors, maybe green and purple? So what Ru is going to do is that, the orchestrator mode, will analyze my prompt. It will see, okay, what this crazy person want to do. And then it's going to call different agents, and it's going to define, okay, I need to do a CSS to style this page. And then you'll say, well, can I call the code mode so I can do the change? So I can just click approve. Then it's going to do some changes in my main.py because, of course, I'm not a very good web designer. So it understands that, I have to go to your do-get method, and I'll use some CSS styling to do that. So while it do its thing, so let's do another thing, right? Let's do the AI work. Let's go to the demo4 folder, and let's check, because Oyama doesn't come with models by default, right? So let's check if right now there's some model available in my Oyama instance. So you see, so I'm querying the same port that I use it to access, and I'm saying that it says that there's 0 models, right? So this is something we gotta fix in order to play around. So I also, have a curl here that will force Oyama to download the models. So I'll just paste this here. Oops, I forgot one. Okay, so now it's pulling a model. So I'm downloading the fee model, that is the sample. So basically I'm using API pull on the Oyama instance and saying what is the model that I want to pull, and it's downloading. So meanwhile here, Ru just came with this nice CSS. I will just save. So yeah, so that's the beauty of Ru, right? So, okay, now I have theoretically a beautiful page made by AI for us. So about Oyama, so if you folks are not familiar with Oyama, there is a Postman API collection with the Oyama implementation. So here, you literally just search for Oyama API Postman collection. Here you see there's all the endpoints that you can use on Oyama, like I want to load the model, I want to list the local models, I want to download models, I want to see which models I have running. So it's really helpful if you're just looking at using Oyama in your local development. So this case here, what we done, instead of using Postman, we just copy the command from curl here and use it to do our test. So I'll just copy this one again for getting the list of models that I have available. And you'll see that, okay, now I have the model 5 available for us to use, okay? So, okay, we have our model. We have our AI-generated CSS style for our application. I would just Control-C here, and I'll go to my compose. I think I want to run a Docker build now for, oops. Is it going to build? Yes, okay, it's building, thank you. It's recreating the other one. Just give it a time. So right now there's nothing running, so, okay. Okay, beautiful. Isn't it great? Like AI is awesome because it can do like these Evangelion style colors so beautifully, right? So I'll just ask for, can you write a haiku about Docker? And I just click generate. And it's thinking. And keep in mind, Oyama is running on my computer on CPU. So there is no OpenAI, there is no remote connection in order to do that. So because of that, some things usually take longer. For instance, making a chat completion request. So I really want to believe that this is doing something. So let's take a moment and wait. So let's go. It doesn't seem that it's working, but let's go back here into our command line. Let's see, our both applications are running. Our request, it's processing. So that's why we avoid live demos, folks. Okay, let's give a stop here. Let's stop our compose here from what is the name, from Visual Studio Code. I would just say Docker compose up here on the separating. Yeah, it's grabbing this, and I'll just click generate again. Maybe it cannot write a haiku about Docker. It maybe can write one about machine learning, right? Okay, you can see here that the request arrived into the Ollama instance. So we can see here in the log that there is this post API generate. So that means that there is a valid connection. Let's give it a little bit of seconds to think. Meanwhile, do we have any question? Okay, it's not thinking. Let's go back to root code here. Let's undo whatever root done. It messed up our code. It was working. Let's stop everything. Okay, let's Docker compose ---- build. Okay, now we have an ugly screen again. Localhost 8000. Okay, this was the ugly screen. So now let's say write a haiku about machine learning. And then I'll click generate. And then you can see that there's a lot of things going on in the back. You see there is the prompting, there is loading the model. So maybe there is a thinking time here. So the connection is going on. The only problem regarding using Ollama, if you're only on CPU, is that it takes time to do the processing. So that is the only detail that I would say that it's important to be careful. But yeah, okay. Sorry, folks. This is not what was planned. So, folks, I'll try to run here. Do we have any questions? I think the idea here is that we are using the API generate from Ollama in order to do that, but for some reason, maybe my computer is too heavy. I can try to just, get rid of a couple of things and see if that will make some difference. Meanwhile, I'll leave the screen open and see if something's going to change. Do we have any questions? I feel okay. So there are questions. Have you integrated LLM model on the Docker container? Any use case?
No.
Okay, no, I saw the questions. Yeah.
Okay.
Okay, let's go through some of the questions. Have you integrated LLM model on the Docker container? Any use case model application? So I will speak a little bit of our experience on TELUS. So on TELUS, everything we deploy has to run on Docker images. So a lot of our integrations had been done using LLM providers. So such as, let's say that I want to integrate with OpenAI and I want to deploy this application. So how do I do that? So Python, like the Docker image, it's the main resource that you need to get your application running, right? So I would say yes, any use case model application. I think any Docker file that you can build and that connects into something will be a valid application. For instance, this one here. This is a valid application. The only change between integrating this using OpenAI is that instead of using Ollama URL and the requests lib, you will be using OpenAI packages, right? So if you can take your app, copy into a Docker file and build the image, then you should be really ready to go to the endpoint. So I believe almost everything runs on the cloud today. runs in Docker containers. So if you have a main Pi app, if you have any app, what you need to do is just copy into the Docker file, and it will be a container. Can you show an example of Docker file for LLM deployment, please? Okay, so LLM deployments, then it will become, how do you want to deploy your LLM, right? So let's say that you have a model that you trained and you want to deploy using Ollama. So Ollama is a very interesting thing because it allows you to load your custom deployment. So let's go to Ollama page. So in Ollama and models, you see that there's a lot of different models for you to use. So DeepSeek, Gemma 3, Quen. So each one of these models, it's formatted into a specific document format, right? So one of ways of doing that, you can train your model. Let's say take your Gemma, do some fine tuning using LoRa, and then export that those weights of your model into a compliant format with Ollama. So Ollama can act as a host. So let's say that you can take your safe tensors file, you can create your model using Ollama, and then you can say, okay, now I want to Ollama run my model. So that would allow you to work, with an open source model, run your self-hosted version of an API that will allow you to publish your method. So I would really recommend taking a look into how Ollama do that, because this is, let's say that you have your model in Hugging Face. So you train your model, you're uploading to Hugging Face. It's fully compatible with the Ollama platform. So I can sort of paste this into the URL and you can take a look and see how it works. I'm sure that Ollama is probably one of the most used platforms to do that. There's more questions. Let's go. So about deploying your own model, I think if you want to do that self-hosted, Ollama will be the easier ways to go. Where can we access the workshop recording after? I think that's something that folks will be able to answer for you later. Can we use that container extension in VS Code? Yes. So VS Code containers, the first step, it's installing dev containers. So you search for dev containers here. I think it's dev containers here. So you install this dev containers extension. Then there is this little green button at the bottom on VS Code. And then you have this option of new development container. And if you have your development container folder, you can just click on reopen in container. And then you pop a message at the bottom saying that we are building your container file. And then you are, boom, into your container. So depending on what you are doing in your container, you have, some building, some installing extensions and packages. So it's depending on like this one is pretty fast. So this is the one that I use for doing the slides. So probably, as you can see, there's not a good stuff happening on my computer right now. So maybe let me just do a prune here. And I'll go to the next question. Prune. Okay. Yeah, but this is how you would do in your VS Code instances. So next one. If your API key is stored in a .env, can the app in the Docker file find that key outside of the Docker container? Okay, good question. So if you have your key outside of your, like on your local computer, let's say, usually the way that you want to pass that into the container, it's via environment file, right? So whenever you do a Docker run, something you can pass your API key and say, this is 1, 2, 3, right? And then your image, my custom image. Yeah, let's say that you were running like this. Okay, so this is one of the ways of doing it. And then when you run Python 3, I think this is going to run Python 3.13, and then being bash. Oops, forgot one thing, -it. Okay, so now if I go and say echo API key, you have 1, 2, 3, right? So it's never a good idea copying API keys within your Docker file. So usually what you want to do is expose these into your environment via something that you can change on execution, right? Because now let's say that your API changed it to, I don't know, 8989, and then, okay, you are going to echo, and then that's going to be your API key, right? So your API changes. So if you are running with environment files, let me do another one here. So I'll just stop this because this is not working. So, okay, let's touch.env. And then here I'll just go and say env that ABC is equal 1, 2, 3, right? So now I'll do the same Docker run that I did before. Docker run minus, I think it's e.env Python 3.13 bin bash. Oops, it's minus M5. It may change, like, okay, I forgot the minus IT. Okay, and then if I do cat ABC, echo ABC, then you have your API key. And then in your M file, you can start adding other variables as well. I think that is the biggest benefit of .env, because you can have, event, and then you can say TMLS, then you can save, then you can run this again, and then say that what is the event? It's TMLS. So you can really start adding and having everything managed. So just make sure you don't commit these files, because that's very complicated. Okay, requisites for deploying Ollama locally. Good question. It's not about Ollama. It's more about which model do you want to deploy with your Ollama. So here I was trying to run Phi, because Phi is a really lightweight model. So in theory, I thought, okay, if I just run this one, is going to be okay, and my computer will not, suffer. Usually, most of the models will have with their recommendations for how much do you need. For instance, let's say DeepSeek, right? So DeepSeek R1, it's 404 gigabytes, right? So it's a bunch of space that you're going to need. So most of the requirements that you have are on the memory front and on the disk front for hosting. So that's where I think you find most of the situations. What is the other one? How do we upgrade Ollama Venture without changing the whole code base? Okay, good question. So because Ollama doesn't run into your computer, it will run on the side. Ollama is a service that you are consuming, just like OpenAI, right? So here, let me go back to my code here. So I'll go to, let me close remote. This is not what I want. Edit locally. So if I go here on the Ollama code, so here you'll see that Ollama is not using not even a specific package. You are just using a standard HTTP request to talk with this endpoint. So here we are literally just calling the Ollama API natively, so using requests. So you are just saying, yeah, just post into API generate, and you expect the answer to get a reply. So you don't have a dependency on the Ollama itself. And then because you are using this as a service, you can change and adapt to the service that you are consuming as the version that you need. So the only dependency that you have, okay, I want to deploy a new version of Ollama side by side to this one, and then you will change what is the URL that you want to use for your application. So you can upgrade, test, and if it doesn't work, then you can roll back and try another one. Okay, I think I got through all the questions. Yeah, if you folks want, ping me later. I can try to answer. I promise I'll try to check what's going on with the Ollama endpoint and see if it's something going on. But that's all that I had for today. Thank you for staying with me. Yuki, do you want to have a message? So thank you all for participating.
I think you have done very well. You even you can even replace me. I mean, yeah. Just make sure are there more questions. If not, I think, yeah, thanks for the wonderful talk and wonderful answers, and also thanks for the Great questions. Yeah, thanks a lot.
Okay, more questions. Sweet. Let's see. No question. Just want to thank you for being so open, and troubleshooting is a very relatable process. Oh, thank you, Matthew. Yeah, I think that we just found the problem. My computer is just suffering. Is a local model run only in local machines, or how run over cloud internet? Okay, that's a good question. So Oyama is literally just like a Docker image that you can run whenever you want. So, okay, let me just rephrase this. So Oyama works locally, so you can run Oyama and run hosted in your own computer. Like you can run, install using the script and run locally any model that you want. However, in this case here that I'm running with the Docker image, you could just do the same in your server, right? You can run Oyama based image, pull the model that you're interested in running, and then just expose this port on your service. And then you are selling your own OpenAI provider, right? The only problem I would say is that it requires a lot of computing power, right? So you can see here, this is just a sample prompt, and it's struggling quite a lot. So I think it may be hard to define, okay, how much resource I need in terms of computing to have these properly running and serving actual answers, right? So it really depends on the model. I think if you have GPUs, probably inference time will get better compared to running just regular, a regular service. Okay, a short haiku. Because also depends on how much do you want to, like, what is the token output generation like, right? So here, for instance, we are just doing very simple testing and all of that. But if you just want to try models, I think there are better tools. Like there is LLM Studio, I believe. Let me open new one, LLM Studio. That, it's from, I don't think it's from Google, but you can download and then run locally the server for doing your testing. You can just, it works very similarly. You can change the model that you want to use. You can set it up, you can test, and then sort of press a button, and then there is a llama serving that as an endpoint. So it works very well as well if you want to try. I can share this one. I think this one is open source as well, so you can check it out. But okay, going back to the Oyama question, once you pick up the model that you want to try, then it's I would say like, okay, you have, here, let me cat the compose again. So you have here your compose, you just, okay, given that I know how cloud providers are these days, so if you just Oyama GCP, for instance, you probably already have, a server that's already pre-made for you. This is in Portuguese. Let me change this to English. It probably already there is almost out of the box ready to go Oyama instance that you can click a button and it's ready, right? So you see this is the default Docker file. And you see this is the idea of this presentation, right? Give you all like a basic understanding of why people write these Docker files and how can you use, right? So here you can see it's very similar to whatever we are doing right now, but this is using the Gemma model. So this is serving this model, and then you would have, so memory 32 gigs, 8 CPUs. So yeah, it's probably more than what I'm giving here. So yeah, I think I can share this one as well. Folks, thank you very much. Appreciate everyone who stayed a couple of minutes extra. Enjoy the evening and the rest of the event. Hope you folks have a good one. Bye-bye.